Okay.
Nah. Dah. Boleh start dah?
Boleh.
Apa dalam topik? Assalamualaikum and good evening. We are from group 1. We'll be presenting about our progress in capstone project. Basically, our company is we are doing a cooperation with Alliance Sdn Bhd, which is a Malaysian-based company that started in 2011, and they are expertise in giving consultancy to manufacturing facility for the journey towards IR 4.0. They are specialized in providing industrial revolution 4.0 solutions such as industrial internet of things, big data, artificial intelligence, cloud computing and industrial software. They also involved in automation, robotic visual solution, machine data extraction, management and visualization. Their company is based in Batu Kawan, Pulau Pinang. So our project team is automation or system integration. Dah. Sampai siapa ni pula ni?
Ucup.
Okay, I will continue. So in problem statement, company industry is reluctant to change their data to collect company industry is reluctant to change their data collection system to IoT planning system. They think that to adopt an IoT system, they will need to buy a new machine. They do not want to change current machine to a new machine because it is costly. So our focus, this project involve creating an IoT system for manufacturing facility. The system will consist of a cloud for data storage and a PLC where the data come from. So the Raspberry Pi is used as a mechanism for the integration between cloud and PLC. Test programming will be required. So at the slide you can see there are 5 steps. The first one is a local, second gateway, third internet, the fourth cloud, and the last is local. For this figure, we can see that the integration between the stage require a connection. For example, in this we use Wi-Fi or internet. So our objective we divide into two. First is to provide a real-time decision making option to the management. Second is to enable remote monitoring of machine. So our performance measure will be measure data produced by the system integration and actual data produced by the PLC. For example, the data produced by the system is measured by the sensor, and the actual data measured by hardware. For example, we use a thermometer to measure the temperature at the room.
Next is our strategy. Our strategy is first one is we want to transfer the signal data from PLC and machine to a gateway, which is Raspberry Pi. Second one is we will communicate the gateway Raspberry Pi to a cloud service where the data pulled by the gateway from the PLC is stored in the cloud. And the third one is allow the data stored in the cloud. And last one, we want to make the database accessible within people in the organization.
So this is our current progress. Okay, share. So this is our current progress. So I can see before this, there are 5 stages that require to create a IoT system. So the first one is a local. So in this stage, we use a DHT22 sensor, temperature and humidity, and then connect to PLC Omron CP1A. So here they require a lot of programming, and at this stage, Encik Azwan will be help us to connect between sensor and PLC. So here there are two figures you can see here. The first one is a simple connection between sensor and PLC. And the second figure is an example of a ladder diagram. So the connection between Omron PLC to the Raspberry Pi. So we use Modbus RTU communication by using a serial communication RS232 or RS485. So in this project we use RS485 because it can maximize the number of connector up to 32 devices, and the network also can be a multi-point. So Modbus RTU communication they divide into two master and a slave. For a Modbus master device is a device request the data and write data to the Modbus slave. So the Modbus slave is some devices respond data to the Modbus master. So each Modbus slave has a unique address for ID from 12247. So Modbus function code. So for each PLC that has their own protocol. So for example, a Siemens PLC, the code function will be 3 and 60. So you can see here there are references that we use in this project.
Next, for the gateway, the first gateway is Raspberry Pi A, which contains Node-RED. Node-RED is a programming tool for wiring together hardware devices, APIs, and online services. It also provides browser-based editor that make it easy to wire together flows using the wide range of nodes in the palette that can be deployed to its runtime in a single click. Basically the flow that we set is like this. So we have create, insert, select, delete, drop, and present pull, and also message payload. Next, in the Node-RED, we also have Node-RED Modbus, which which is a Modbus serial that support and works with device that uses serial line RS485 and RS232. So it is compatible with our PLC. And then uh, for the database, we use SQLite node, a node read node to read and wire a local SQLite database. So from all the flow, it will produce a chart as a database from the PLC data produced by the PLC. Next, cloud computing and monitoring. This require a number two Raspberry Pi to the Node-RED. Node-RED can run as a cloud application, and it also provides cloud-done database instance and collection of nodes that make it easy to access. So for example, all the input that is inserted will be stored at SQL database. And the last one is local, which is human machine interface. That this will be the dashboard that as a user interface that connect a person to the device. Node-RED can run as Node-RED dashboard, and it will create a live data dashboard. HMIs communicate with programmer PLC and input or output sensor to get and display information for users to view. And it can be used for single function like monitoring and tracking, or for performing more sophisticated operation depending on how they are implemented. So this is the example of Node-RED dashboard. Uh, Next, for the demonstration.
So basically for the demonstration, I will share our current progress on our project. So basically, as what Shamin said before, Node-RED will be our database whereby the data will be flowed from the inject node to the to our database, and it will be sent to our debug message here. So basically from this flow, the first inject button, inject node is for us to create a table which a table name DHT readings, where we have integer for the primary key auto increment, temperature, humidity, and current date, whereby we can uh, we can set the type of data we want to produce here. So by clicking the node here, it will create a DHT readings table. From this demonstration, the table already created, and next is for the insert of the data, where I put the data for temperature, humidity, and current date, which with a value. However, for in this project, we can connect this node with a Modbus node, where it can read the node from Modbus and can transfer the data to the database here. And to when as for example, I have insert two data to this table, and I can select these two table to show the data again. Here it will produce two data, ID1, and second one is ID2. And to delete these two data, we can just click delete, and it will delete the data. So this is will be our our SQL or database, whereby it will save the data to the Raspberry Pi, which is the data is saved in TMP, the 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 file here. As when we go to the Raspberry Pi, as we go to the Raspberry Pi, we can click to the file manager and search for the file that is stated before, TMP, SQLite, and test2db here. We will see the DHT reading database already stored here, whereby here is the column that we already stated in the programming. Basically, Node-RED is using Python programming for it to function. And everyone can access the Node-RED if they are using the same same network or internet. For example, here is our Raspberry Pi, and I open from my laptop by just using this IP address. So the next thing that we have from our slide before uh, is cloud storage, where we store the data, and also the human machine interface. For the human machine interface, Node-RED is capable of displaying or visualizing the data that we have. From here, we can see that I use this example to show how it works. For example, for the first one, I create a table. Names temperature. Then I input the data to the database here by clicking this timestamp. I can set when will the data will be injected to the system. Uh, then, as you can see here, the data will be stored in the system, and to enable the data to be read, to be displayed, I put a chart for the data to be displayed. As for this, I inject to the UI every 1 second, and then as I said before, I put a chart here. So to see the data shown, we can access the UI from our local host port 1880 UI. So basically, from here, we can see that the data will be stored in the chart. And to show our user interface, I also include our switch, color picker, and slider and gauge to see how it works. Sorry. As you can see here, the as I said before, I have put the node rate, the data from the node rate to a chart. The chart that I use here is the line chart, and you can see that it appear here, so that user can monitor the real-time data from the, if we connected to the PLC, it will show the real data from the PLC. So basically from our project, the thing that we face here is our dashboard UI is only accessible to the local network, which is a device that is connected to the same network. If we want to enable the data to be displayed, we need to open port 80 from router, and everyone can access the data, and we can create an Android apps or display it to the monitor. And the second problem that we face is the security function of node rate, where everyone can access the dashboard as long as they're connected to the same network. And the third one is SQLite node is not very stable, whereby I found out that when I shut down the Raspberry Pi, the database that I have stored, that I have running, it will deleted or missing. And the fourth one is, it is complicated to get the data from Modbus, as the data come with JSON format, need function node with Python code programming to transform the data into readable format. And so that we can inject the data to our database. So that's all from us. Okay, thank you. So don't forget to subscribe and click the button like here and share to your friends. Thank you.